Everyone, welcome to my YouTube channel Tutorial Home My Electrical. In today's video, I will going to discuss the part 2 of top 100 question answer series of measurement. In previous video, I have already discussed the part 1 of this series. If you yet not watched that part, please watch that part from the given link in the I icon. And if you like this video, please like, share and subscribe the channel. So let's start today's video. In previous part, I have already discussed the 3 questions. So in this part, I have start with the fourth question. So the fourth question, if a DC voltmeter is made from an ammeter having full scale deflection of 100 microampere, then its sensitivity in kilo ohm per volt. The question is asked the sensitivity. What is the sensitivity? The sensitivity in kilo ohm per volt. We know the unit of sensitivity is ohm per volt, but in the question the sensitivity asked in kilo ohm per volt, and the full scale deflection is given. So the IFSD, full scale deflection, IFSD is 100 microampere. Okay, 100 microampere means 100 into 10 to the power minus 6. So we know the sensitivity is the inverse of IFSD. So inverse of IFSD is the sensitivity. So if I put the value of IFSD, then 100 into 10 to the minus 6 means 1 divided by 10 to the minus 4 is equal to 10 to the 4 ohm per volt. This unit is ohm per volt. Ohm per volt. Okay. This ohm per volt. But they asked in kilo ohm per volt. So 10 into 10 to the power 3 ohm per volt. If I rewrite this, so 10 kilo ohm per volt. Okay, so the answer is 10 kilo ohm per volt. 10 kilo ohm per volt. Okay, going to the next question. Next question means fifth question. Okay, in fifth question, the difference between indicated value and true value of this quantity of a quantity is known as. Means difference between indicated value and true value of a quantity is known as. We know the difference between indicated value and true value is the absolute error. Okay, option A is Gauss error, B is absolute error, C is dynamic error, D is relative error. Correct answer is absolute error. Going to the next question. Next question means sixth question. They asked loading effect is primarily caused by instrument having. We know the loading effect is primarily caused by instrument having low sensitivity. Option A is high resistance, B is high sensitivity, C is low sensitivity, D option D is high range. We know the correct answer is low sensitivity. Okay. Going to the seventh question. When reading is taken at half scale in the instrument, the error is exactly, option A is exactly equal to half scale error, option B equal to full scale error, option C less than full scale error, option D more than full scale error. We have to know the here what is full scale error. What is full scale error? Full scale error. What is full scale error? What is full scale error? Full scale error, we denote the full scale error FSE equal to absolute error. Absolute error. Absolute error by spam into 100%. Okay. Full scale error is assume late meter is given this is 0 volt, this is 100 volt. Okay, 100 volt. What is full scale error? FSC. Full scale error. Full scale error is absolute error by spam. So 1 into 100%. Okay. Into 100%. We let the dV equal to 2 volt. Here we assume the absolute error is 2 volt. Okay, we may assume 10 volt, 5 volt, etc. We had assumed 2 volt. So here 2 volt, span is 10 volt, 100%. So 20%. Here full scale error is assume absolute error 2 volt and span is 10 volt. The full scale error is 20%. If the scale is measured in, they asked scale is measured in half scale. When the reading is taken at half scale, so the reading is taken, assume here 5 volt. Now the span is 5 volt. Now span is 5 volt. Now the FSC, now the FSC equal to 2 volt by span into 100%. Okay, 2 by 5 to 100% equal to 40%. So if the span is decreased, then the full scale error is increased. Okay, so the correct answer is more than full scale error. Okay, when reading is taken at half scale in the instrument, then the error is more than full scale error. Okay, more than full scale error. Going to the next question, means 8th question. Okay, next question is asked, the torque weight ratio of an instrument indicates. They asked torque weight ratio of an instrument indicate. Option A is selectivity, option B accuracy, option C fidelity, option D sensitivity. So if we know the sensitivity is equal to change in input divided by change in output. Okay, so it is delta theta divided by delta I. Okay, now for PMMC, assume for PMC. Okay, for PMC we know the delta theta proportional to deflection. So we may rewrite here that torque, we know the current is proportional to cross section area, and we know the I is proportional to cross-sectional area. So here cross-sectional area. If cross-sectional area is also proportional to the weight. Okay, so the sensitivity is proportional to the torque and weight ratio. Okay, so the answer is sensitivity. We prove here that sensitivity is proportional to torque weight ratio. Now going to the next question. Okay. In next question, they asked a 10 milliampere meter has the accuracy of plus minus 2%. Its accuracy while reading 50 milliampere will be. Here we have to understand one question that one. Here we have to understand one situation. We have to understand one situation that one is accuracy and another is accuracy error. Accuracy error. Accuracy is denoted as 1 minus, and accuracy error is denoted as absolute error by span into 100%. Okay. So, and also we have to know that accuracy is always tends to 100%, and accuracy error is always tends to 0%. So understand, accuracy is always tends to 100% and accuracy error is always tends to 0%. So here the accuracy is given accuracy error. Okay, accuracy error. So now they given the accuracy error is accuracy error as plus minus 2%. Okay, plus minus 2%. We know the accuracy error is absolute error by span into 100%. Absolute error plus minus 2% by 100%. Okay. So the is plus minus equal to 100 milliampere into 100%. So the equal to this 100 cancelled, so plus minus 2 milliampere. Okay. Now they asked what is the error when the span is 50 milliampere. They asked when the span is 50 milliampere. When the span is 50 milliampere. Okay, span is 50 milliampere. So if I calculate accuracy in the span of 50 milliampere, then accuracy here the accuracy error समान d by 50 milliampere into 100%. Now d is minus 2 milliampere by 50 milliampere into 100%. So the milliampere cancelled with 2. It is plus minus 2. Plus minus 4%. Okay, the answer is plus minus 4%. Answer is plus minus 4%. Answer is plus minus 4%. Option D is correct answer. Okay. Now going to the next question. Next question is precision current shunt is measuring 50 millivolt across it and also indicate a current of 30 ampere. What is the actual resistance of the shunt? So if I draw the question here, it is internal resistance RI. Okay, এখানে একটা here a shunt is connected here. Shunt is connected. The voltage across the shunt is 200 millivolt. Okay, 200 millivolt. Now also indicate current of 30 ampere. Means here 30 ampere is flowing. 30 ampere. This is RSH. Okay, so the RSH is voltage by current. Voltage divided by current. What is the voltage? 200 millivolt. 200 millivolt. What is the current? 3 ampere. Okay. So 200 into 10 to minus 3 by 30 ampere. 30 ampere. It is 6.6 into 10 to minus 3. 6.6 into 10 to minus 3. So equal to 0.006.6. Oh, then it is over. So nearly equal to 0.006. Oh, okay. So the correct answer is 0.006. Okay. So we have discussed the so far we have discussed the 12 question. Okay. If you in the next questions we will be discussing part 3 of this series. If you want notification of the part 3, please push the bell icon on my channel and subscribe my channel. Okay. So thank you. We'll meet again in next part 3. Till then, keep preparing and bye. Okay. Thank you. Again, thank you. Keep preparing.